Hi, welcome to the Myths and Facts in Statistics Series 6. I am Dr. J.K. Sachdeva. Today, again, we are entering into a very serious issue in regression. Another very common reason for rejecting regression based research is the presence of heteroscedasticity in the residuals. Reviewers often conclude that because residuals variance is not constant, the OLS regression is invalid. This conclusion, however, is statistically incorrect. Classical linear regression assumes homoscedasticity error for driving standard errors and test statistics. Over time, this assumption was misunderstood as a requirement for unbiased estimation, which it is not. The confusion lies at the heart of heteroscedasticity myth. Myth 1 versus fact 1. A widespread myth is that heteroscedasticity invalidates OLS coefficients. As clearly explained by Woolrich, heteroscedasticity does not bias OLS estimates and does not affect their consistency. The estimated coefficient remain correct on average. Myth 2 versus fact 2. Another misconception is that heteroscedasticity destroys hypothesis testing. White's seminal 1980 paper showed that heteroscedasticity robust standards correct the inference problem without changing the regression model. Thus, the solution is adjustment, not rejection. Myth 3 versus fact 3. Researchers are often advised to transform data to fix heteroscedasticity. Gujarati and Porter caution that such transformation can complicate interpretation and are unnecessary when robust standard errors are available. Transformation should be theory driven, not automatic. What it really affects. Heteroscedasticity affects the estimated variability of coefficients, leading to incorrect t statistics and confidence intervals if ignored. It does not affect the unbiasedness of coefficients or overall structure of the model. What should be done? Good practice involves diagnosing heteroscedasticity, applying robust standard errors when needed, and clearly reporting the method used. This approach is widely acceptable in modern applied research. To conclude, heteroscedasticity is not a reason to discard OLS regression. It is an inference issue that can be corrected with well established methods. Let us understand heteroscedasticity with a simple applied example. Suppose we are studying the relationship between household income and household consumption using cross sectional data. Our model specifies consumption as a function of income. We estimate this model using Excel or EViews with ordinary least squares. The estimated income coefficient is positive and statistically significant, and overall model appears reasonable. Next, we examine the residuals by plotting them against income. What we observe is a clear fan-shaped pattern. For low-income households, the residuals are tightly clustered, while for higher income households, the residuals spread widely. This pattern indicates heteroscedasticity. Now comes the crucial points. Even after detecting heteroscedasticity, the OLS coefficients do not change. The intercept, the slope coefficient, and the fitted values remain exactly the same. What does change are the standard errors, because the assumption of constant variance is violated. The usual standard errors are no longer reliable, and therefore the reported t statistics and confidence interval may be misleading. To correct this, we apply White's heteroscedasticity robust standard errors, which are available in eViews, SPSS, R, and through add-ins in Excels. After applying robust standard errors, the coefficient remains unchanged, but the standard errors and t-values are corrected, restoring the valid statistical inference. This worked example clearly demonstrates that heteroscedasticity affects inference, not the validity of regression model itself. One, heteroscedasticity changes t-values, not coefficients. Let us conclude heteroscedasticity changes t-values, not coefficients. Thanks for watching. Please share with your friends who are interested in advanced statistics and econometrics. Thank you.
Always share the videos of Dr. Sachdeva to your friends who are interested in data analysis.